Alright, I think I'm live now. Can someone confirm in the chat if I'm live or not? Okay, we have 9 people in the stream right now. That's good. Okay, is my audio perfectly clear? Let me check the lag. Okay. Yes, Vimal says yes. Okay, perfect. Okay, cool. Let's start with the stream then. Okay, so we are going to solve problem A, B, C, and D of today's contest, Hello 2022. Okay, so I'll wait for a minute for some more people to join and then we'll start. Okay, cool. Okay, I think we can start now. Can people tell me like how many problems they were able to solve today? In today's contest, I think like they were like more like implementation problems only, no specific logic or something. Okay. Okay, I hope everyone can see the questions now. No, it's not a Dev 1 round, it's a Dev 1 plus Dev 2 round. Okay, let's start with the very first problem. So, the problem says that you have an n into n chessboard and k rooks. Rows of this chessboard are numbered by integers from 1 to n from top to bottom, and columns of this chessboard are numbered by integers from 1 to n from left to right. The cell xy is the cell on the intersection of row x and column y for x less than equal to n and y less than equal to n. Okay, perfect. So basically, the problem says that we're given an n into n grid and the xth row and the yth column has a cell numbering of xy. Then the arrangement of rooks on this board is called good if no rook is beaten by another board. A rook beats all the rooks that shares the same row or column with it. Okay. So the good arrangement of rooks on this board is called not stable if it is possible to move one rook to the adjacent cell. So arrangement becomes not good. Otherwise, the good arrangement is stable. Here, adjacent cells are the cells that share a side. So what I think is that the text of the problem is not very clear. I myself had to like read it like 3-4 times to understand what it is actually trying to say. So I'll just show you everything like what it is trying to say. So let's say we have a grid of 5 into 5. Okay. Okay, let's say this is the grid 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, now we are supposed to put rooks in this such that the orientation is stable. What they mean by that is, let's say we have rooks here like this. Okay, let's say we have 3 rooks only and they are placed like this. Okay, now what they're trying to say is that if we move this rook by 1 to any of the adjacent places, it will actually cancel out any other rook, which is not expected. Okay, what they want is that we need to have rooks in such a way that if we move any of the rooks by 1 in any of the adjacent cell, then they should not beat any other rook, which means we need to have a distance of at least 2 in every rook. So basically, if we place the first rook here, the second rook has to be here and the third rook has to be here. If you place this rook anywhere, like let's say if we place this rook here, then it is beaten by this one. If we place it here, then if we move this rook by 1, it will be beaten by this one. Or if we move this by 1 in the downward direction, it will be beaten by this one. If we put it here, it is beaten by this one. Similarly, if we put it here, then if it moves 1 up, it will be beaten by this one. So this is the only position where we can keep this. which actually tells us that if n is 5, we can place 3 rooks. Similarly, let's say if we had 4, n equals to 4. If n was 4, we would have been able to put 2 rooks only. So if n equals to 4, only 2 rooks are possible. If n equals to 5, only 3 rooks are possible, which actually tells us that for n plus 1 by 2 is the required number of rooks. Because for even we have n by 2, and for odd we just need to add plus 1. So both these statements are same only. Okay, and how do we place them? We need to place the very first rook at the 1 1, the second at 3 3, the other at 5 5. So basically at every odd configuration. Okay, so I'll just show you the code, like the code that I wrote for this one. Okay, so yeah, this is the code. So basically I'm just checking if k is less than equal to n plus 1 by 2. If it is, that means we have a possible orientation. Otherwise we just print -1, and then I just make this one only. Like I have the first rook at 1 1, then 3 3, then 5 5, and that's it. Okay, cool. I hope this is clear to everyone. A pretty easy problem. I think the statement was a little confusing. That's why like you might have taken a little longer to solve this one, but I think everybody got this right. Okay, cool. Let's move on to the second problem then. If anyone has any problem with the first problem, they can just let me know in the comments. I'll just repeat everything. Okay. All right. Let's move to the second one then. So the second problem says that the integer shop sells n segments. The ith of them contains all the integers from L1 to R1 and costs C1 coins. Tomorrow, Vasya will go to the shop and will buy some segments there. He will get all integers that appears in that at least one of the bought segments. The total cost of the purchase is the sum of the cost of all segments in it. So basically, we are given some n segments from, like, every segment has a Li and Ri, and the cost of that segment is C1, Ci. Okay, cool. Now, after shopping, Vasya will get some more integers as a gift. He will get integers x as a gift if and only if all the following conditions are satisfied. So Vasya hasn't bought x. So basically she wouldn't have bought x, and x, there is an integer that Vasya has which is less than x, and there is an integer which is greater than x. Okay, if these three conditions are satisfied, then she will get that particular integer as a gift. Also, one integer she will get as a gift only once only, so she won't get x twice. Okay, alright. So basically, for example, if Vasya buys segment 2 4 for 20 coins and segment 7 8 for 22 coins, so if you see, by 2 4 it means it has 2 3 and 4. By 7 8 it means it has 7 and 8. Now if you see, there are two variables in the middle, which are two integers in the middle, 5 and 6, which means she will get 5 and 6 as a gift. So basically, with the total sum of 20 plus 22, which is 42, she gets 2 3 4 7 and 8 and 5 and 6 as a gift. Okay, cool. Due to technical issues, only the first S segment, that is segments till S, will be available tomorrow at the shop. Vasya wants to get as many integers as possible. If he can do this in different ways, he selects the cheapest of them. Okay, cool. So basically, let's look at the examples now. Okay, so in the very first example, if you see, there are two segments. Okay, I'll just write down these. Okay, and then explain. Okay, till what number did you compute before coming to the formula of n plus 1 by 2? Actually, if you look at the even cases, you'll see that it is n by 2, and then after that, if you get an odd row and a column, then you see that you need to add one more row to that. So that makes n plus 1 by 2. Okay, cool. Okay, so let me just draw the cases now. So in the very first test case, we have 2 4 as a segment and it has 20 coins. The second has 7 8 and it has 22 coins. Okay, cool. Let's say Vasya had only the first segment. Then she would have to take this interval only, and she would have integers 2 3 and 4 with a cost of 20. Okay, so if you see at the very first case, the answer is 20. Then if she gets both these values, okay, then she has a segment from 2 to 4 and she has a segment from 7 to 8. Okay, this has a cost of 20, this has a cost of 22. Okay, and she gets 5 and 6 as gift. Okay, so the minimum cost is 42 and the variable she's getting is 2 3 4 5 6 7 and 8. Okay, and there's no better way of doing this. Okay, let's jump to the second test case. Okay, so the second test case, okay, let's take the last one, which is I think a little better. So we have 1 4 for 4, 5 8 for 9, 7, 8 for 7, 210 for 252, 111 for 271, and 110 for 1. Okay, all right. Let's say we had the very first interval only. So we have an interval from 1 to 4, and the cost of this is 4. So the only option we have is to take this interval only, and the answer for this one is 4. Let's take the second interval also now, 5, 8. So we have 5 to 8, okay, and it has a cost of 9. Now we can take both these intervals, as these will increase the number of integers that Vasya has, and the sum of these will be 4 plus 9, which is 13. Then let's come on to the next case, which is 7 and 8 with the cost of 7. So we have 7 and 8 with the cost of 7. Now if you see, Vasya doesn't need this interval, because she can take this interval and she will have like 1 and 4 and 7 and 8, and she'll get 5 and 6 as gifts. Okay, so the sum of 4 and 7 is actually 11, which is less than 13. Okay, so we'll have 11 here. We might have taken 13 also if the number of integers would have increased, but since both these cases give us the same integers, therefore we are going to take which has lesser cost. Okay, so this has 11. Then in the next case we have 2 to 10 with the cost of 252. Okay, now we have a segment from 2 till 10 with the cost of 252. Now if you see, if we take this interval, we actually get 9 and 10 as well. And that is why it is necessary for us to take this interval and the very first interval. And the sum of these becomes 252 plus 4, which is 256, which is the answer for this case. Then let's say we get this case as well. Now we have 1 till 11. Okay, let me just, I'll just put it 1, 10 till 1. Okay, now we have another case from 1 till 11 with a cost of 271. Okay, now again, if you see, if we take this interval alone, we get the maximum number of integers, which are from 1 till 11. In any other case, there is no way we are going to get 11. So we need to take this interval only, and the cost of this becomes 271. Okay, then the next case is 1, 10 and 1. Okay, so we have another interval from 1 till 10 with the cost of what's the cost? 1. Okay, now if you see, we need 11, which is the necessary part. Okay, therefore the only case we need to take is 1 to 11. We can also take 1 to 10 and 1 to 11, but then if you see, there is no use of taking 1 to 10 because 1 is already covered with this interval. Therefore the answer for this one is also going to be 271. Now if you see, the only two things that we care about is L and R. The minimum L that we can get and the maximum R that we can get. Okay, so I'll just frame an example to make you understand this one. Okay, let's say, I'll just remove these as well. Okay, let's say we had an interval 2, 5, and the cost of this was 5. Okay, we need to take this interval since it is the very first interval. Next interval, we say, let's have 8 to 10 with the cost of 2. Okay, so we have 2 to 5 with the cost of 5. We have 8 to 10 with the cost of 2, and we need to take both these intervals. Therefore the answer for this would be 7 for now. Let's say now we get another interval with 2, 10, and the cost of this one is 6. So we have another interval from 2 to 10, and the cost of this one is 6. Now if you see, we can either take this interval alone, because this will give us 2, 3, 4, 5, 6, 7, 8, 9, 10. Or we can take both these intervals, because these will get 2 to 5 and 8 to 10, and it will get 6, 7 as a gift. But the cost of these two intervals is 5 plus 2, which is 7, and the cost of this one is 6. Therefore, it is better to take this alone interval only, even if we have all these three intervals. So if you see, let's say now, this 8 to 10 was actually 8 to 11. Sorry, 8 to 11. Since it is 8 to 11 now, it becomes necessary to take this part as well, because it gives us 11 as well. Now the answer would be 7. Because we need, in order to get the maximum integers, we need to take this 5 and this 2, and the sum of this is 7. So as you can see, we need to minimize L, okay, and we need to maximize R. Okay, And that is all we have to do. So basically you need to find the interval with the least L and the maximum R, and then just add the cost. Now there is one edge case that you need to consider. Okay, let's say, okay, this one only. We had 8 to 10 and the cost was 2. Okay, so basically we had from 2 to 5 with the cost of 5 and from 8 to 10 with the cost of 2. Okay, we might say that the minimum L that we have, right? Okay, let's add some more intervals as well. Let's say we have 3. Okay, let's say we had a few more intervals, 3 to 4 with the cost of 10. Okay, and we had an interval, let's say 6 to 9 with the cost of 8. Okay, the very first interval comes in 3 to 4. We say this is the only interval we have, and hence the answer for this one will be 10. Okay, the next interval comes in which says, okay, our L right now becomes 3 and R right now becomes 4. Now we say that the next interval is 2, 5. So we have 2, 5 and the cost of this one is 5. Now we say that our L is also changed, our R is also changed, and the answer for this one becomes 5. Then we get 8 to 10, which actually tells us that we have another interval now, 8 to 10, and the cost of this one is 2. So we need to update R now because we have a different R, and we need to add the value of this, the interval which gives us this R and the interval which gives us this L. So we need to add 5 plus 2, which gives us 7. Okay, then we get 6, 9. Okay, we get 6, 9, 6 till 9, and it has a cost of 8. We say that since 6 is greater than L and 9 is less than R, therefore we don't need to change anything. Okay, then let's say we get another interval which has 2 to 10 with a cost of 6. 2 to 10 with a cost of 6. Now we say that L is equals to L only and R is equals to R only. But this is an alone interval, therefore we need to take we might have to take this one if the cost of sum total cost of this one is less than all the other intervals. Since this 6 is less than 7, we can say it is 6. Now how to implement this? All you have to do is, after getting every interval, you just have to store that interval in a map. Okay, so that whenever you have this L minimum and R maximum, you just have to see if there is any interval which has this L and this R. If there is any such interval, you just need to compare the previous answer with this one. Okay, I'll just show my code as well. I hope the logic is clear to everyone. Okay, and I'll even show my code so that it becomes more clear. Okay. Okay, so this is how I wrote the code. So basically I have a min L, which is this one, and a max R and cost of L also. So I have a cost L and cost R. Okay, so basically this cost L stores the cost for the interval which we from which we have this min L. This cost R stores the cost of the interval which gives us max R. Okay, then for every interval we just scan them. We check if, okay, so basically there's another edge case. There might be two same intervals. So you need to have in the map the least cost of that interval. Okay. Okay. And then I just check if L is equals to min L, then I just have to see which interval has the least cost. If L is less than min L, then I need to add, change my min L to the current L and change my cost to the current cost. Similarly for R as well. Okay. And in the end, I just need to check if I have a pair in my map which has min L and max R. If there exists a pair, then I need to check maybe this interval might have a lesser cost than the previous two intervals. So I just need to check which one is minimum and print that out. I hope this is clear to everyone now. Okay. Okay, so basically what I'm doing is I'm actually storing the minimum L that we have and the maximum R that we have. Then for every minimum L, I have a cost from which interval it came from, and for every maximum R, I have a cost from which interval it came from. Okay, then there might be a case that the interval from which we get minimum L and maximum R are both the same. If that's the case, we just need to check in the map, and if we find that, we just need to update our answer. I hope it is clear now. Okay, Gaurav says your explanation made it simpler. Should have thought of using map of pairs. Yes. Okay, cool. That's it for this problem now. Let's move on to problem C now. Shall we? Okay, cool. Okay, C again is a simple problem. You just need to understand like what they're trying to say. It's an interactive problem, so maybe for someone who's a beginner might not know how to solve interactive problems. So yeah, you will that learn in this stream as well. Okay, cool. Okay. I'll just rub everything. How many people in the stream were able to do C? Okay, cool. Okay, let's move on to C now. Okay. So the jury has a permutation P of length n and wants you to guess it. For this, the jury created another permutation Q of length n. Initially, Q is an identity permutation. You can ask queries to get Qi for any I you want. After each query, the jury will change Q in the following way. At first, the jury will create a new permutation Q dash of length n such that Q dash I equals to QPI for all I. Then the jury will replace permutation Q with permutation Q dash. You can make no more than 2 inquiries in order to guess P. Okay, cool. Let me just move to my board and like help you understand what the problem is trying to say. And I'll take example of the very first test case in which the permutation is 4213. Okay. So, okay, let's move to the board now. Okay. So basically the permutation that we have is 4, 2, 1 and 3. What we are given is that after every query, what it does is it makes another permutation or a sequence, we can say Q dash, and Q dash I is actually equals to Q of Pi, which means Q dash 1 is actually going to be Q of P1, Q dash 2 is actually going to be equal to Q of P2, Q dash 3 is actually going to be equal to Q of P3, Q dash 4 will be equal to Q of P4. Okay. Now, let's say we ask any query. Okay. Now, the very first thing that you can see is actually, after every query, we are actually doing this for all the integers. Therefore, whatever query we ask doesn't matter. The permutation will, the new Q permutation will always be the same. Okay. Let's say we ask for the very first query only. That, okay, we are asking that query is equals to 1. The jury will make a new permutation Q dash. Okay, so this is Q dash. Okay. Oh, sorry. Initially we have a Q permutation which is an identity permutation which is 1, 2, 3, 4. Now the jury will make a new Q dash and it will say that Q dash 1 is actually going to be equal to Q of P1. Now Q of P1. P1 has 4. Okay. So Q of 4 is 4. So we'll have 4 here. Now Q dash 2 is actually going to be equal to Q of P2. P2 right now is 2. Q2 is 2 only. So we'll have 2 here. Then again, Q dash 3 is actually going to be equal to Q of P3. P3 right now is 1. Q of 1 is 1. So we have 1 here. Okay. Then again, Q dash 4 is equals to Q of P4. P4 right now is 3. Q of 3 is 3. So we have 3 here. Okay. Let's say we again ask the query 1. Now this Q dash becomes Q, the updated Q that we have. Now the jury makes another Q dash. Now Q dash 1 will be equal to Q of P1. P1 right now is 4. Q of 4 is 3. So we have 3 here. Okay. Then Q dash 2 is actually going to be equal to Q of P2. P2 right now is 2. Q of 2 is 2 again. Then Q dash 3 is equals to Q of P3. P3 right now is 1. Q of 1 is 4. Okay. And Q dash 4 is equals to Q of P4. P4 right now is 3. Q of 3 is 1. Okay. Let's do this one more time. Okay. So let's say we ask any query. Let's say we ask for 1 only. Okay. Now this becomes Q. the updated q, and the jury now again makes a q dash. Okay, for this one we have q of p1. P1 right now is 4. Q of 4 is 1. So we have 1 here. Then q dash 2 is equals to q of p2. P2 right now is 2. Q of 2 is 2. Q of p3. P3 is 1. Q of 1 is 3. Then q dash 4 is equals to q of p4. P4 right now is 3. Q of 3 is 4. And we are back to the identity permutation. Okay. So, okay. So basically, if you see, we actually had, so if n was 4, we actually changed it 3 times only. Okay. So this was the initial permutation, that initial q that we had, and we had to change it 3 times to get the identity permutation back. Now, okay. Something that you need to notice here is that when we are asked, okay, so basically when we make q dash 1 equals to q of p1, we are actually asking that whatever we have in p1, you need to take that particular index from q and put it at q11. What it means is that at the first position in my permutation p, I have 4. Then again, when I do this again for the very first index in this q, I say that in the fourth index of p, I have 3. Then again, I say that in the third index of p, I have 1. So in the third index, I have 1. So basically, whenever I'm making query 1, in every query, I am getting these values. Okay, that if I had asked for 1, that means at the very first index, I had 4. Now, since the last value was 4, therefore, I know that in the very first value of q, I have 4 now, and this permutation will have a 3 now. And similarly. So basically, if you can see, we actually have a cycle. Okay. So the cycle is that 4 comes at 3's place, 3 comes at 1's place, and 1 comes at 4th place. And the cycle keeps on moving. Even if we do this like 100 times, this is the same cycle that will keep on moving on. And 2 has an identity cycle. That means 2 keeps on moving into itself. Okay. So this was the key part that you had to understand in this problem. So basically, okay, let's see how many maximum queries that we can make. Okay, let's say this p was 1, 2, 3, 4 only. Then for the very first index, we had to make 2 queries in order to check that, okay, the cycle is complete. After starting from 1, we get 1 only. If you see in this one, we started from 4. Okay, sorry, we started from 1. And in order to get to 1, we had to make 3 queries. But if it is already 1 in the permutation p only, then we only had to make 2 queries in order to get back at 1. Because in the very first query, we would get 1. And in the next query also, we would get 1, which means that 1 has a cycle of itself. Similarly, for 2 also, we'll have to make 2 queries. For 3 also 2 queries. And for 4 also 2 queries. Which means the maximum queries that we had to make is 2n queries. And that is why we are asked that the maximum queries that we can do in this problem is 2n. But it is obvious that there will be cycles. Let's say a cycle has 3 values. So basically in this cycle, we had 3 values. Okay. If there were 3 values, then we had to make 3 queries only. Sorry, 4 queries, I think. No, 3 queries only. Okay. So basically, if I have a cycle of x integers, then we'll have to make x queries only. Okay. But if it is 1, then we have to make 2 queries. I think it should be x plus 1, because for the very first query, we got this one. For this one, yeah, it should be x plus 1. So basically, for every x query, a cycle of x integers, we have to make x plus 1 queries. So if x is equals to 1, then we have to make 2 queries only. And since like 2 has a cycle of itself, that means x again is 1, therefore 2 cycles. Okay. Yeah, that's pretty much it about this problem. All you had to do was find cycles, see which one is replacing which integers, and with that you could actually get the integers in the permutation. Okay, I'll even show you my implementation, like how I wrote the code. So, okay, where we are, okay. Okay, cool. So basically what I did was I actually have a v vector, which is my answer vector. This visitor tells me which all values I've already gotten when I was making queries. Okay. So then what I do is from 1 to n, I just make a for loop. I see if I've already gotten this value or not. If I haven't got this value, I just keep on making queries for that particular I only. And I keep on getting the values of the cycle. So basically in the very first index, I'll get 1, then I'll get 4, then I'll get 3, and then I will again get 1. Okay, so basically I'll have a cycle of 1, 4, 3, and 1. And I'm also mapping these values. So basically I'm making it every value that I get, I'm making vi equals to m of I. So basically when I had 1, I had like mi was 4. Okay. Then when my mi becomes, vi becomes 4, I have mi equals to 3. Then when my vi is equals to 3, I have mi equals to 1. Okay. Because that is my answer vector. And I had to store all these values in the cycle. Okay. So I hope this is also clear. A little difficult to understand, I would say, in the first try. But if you actually like see that, okay, we have some cycles, we have some disjoint sets that are being made, then it is easy to write the code. Okay, and as always, you just had to flush the output in the end, and you had to write like end all to flush the output after every like printing. Okay, I hope this is clear to everyone. We can move on to problem D then. Okay, cool. D, okay, I already have it here. Okay, I don't see any chart. Okay, cool. Let's move on to problem D then. Okay, I'll just rub everything. And instead of reading out the problem D, I think I'll just explain to you what the problem is saying, because the statement is very big. So I'll just like explain on the board what the problem is trying to say. So what we have is, we have a grid of size 2. So basically this is 1, 2 till 2n, and we have 1, 2 till 2n. This is our x, this is our y. Okay. Now we can actually divide this grid into 4 parts. This is the top left, bottom left, top right, bottom right. Okay. In every cell of top left, we have people standing. Okay. So if we have someone here, someone here. So basically in every cell of the top left box, we can say we actually have a friend. Okay. And in every other cell, in rest of the cells, we might have, okay, so I'll just outline these as with the red one. Okay. Now in these boxes, we might have some snow. Okay, so I'll just make those. Yeah, okay, that's it. Cool. Okay. Okay. So let me just explain the operations first. Okay. So what the problem says is that, let's say this is a grid, okay, of like 4 into 4. These color dots are our friends. So we have friend 1, friend 2, friend 3, and friend 4. This blue actually says that we have snow here. Okay. So there are 4 kinds of operations that we can do. Okay. The very first operation is that we can move our friends in a row. The second operation is that we will move our friends in a row in the backwards direction, and similarly in the columns as well. So basically they have actually showed us one operation here in which they are moving them in a row in the backwards direction. Okay. So they are actually using this row, the second row, and since it's a forward direction, I would say. So this green from this part comes to the next column, which is this one. This red goes in a cycle to the topmost column. Okay, so that is what the problem is saying. Okay, so similarly, let's say if we had this particular arrangement only, and we had to move in the first column in the forward direction, then this green would have reached here, this orange would have reached in the very first row. Okay, one more thing, if so, let's say that we had to move this row in the backwards direction. Okay, this green would have reached in the place of this red one, and this red one would have gone at the snow part. If any friend goes to any snow part, then he gets ill, and that is not something that we want. Okay, Now we have an option that we can actually remove the snow from a particular cell with some cost. Okay, we are given that cost for every cell which has snow. So I'll just jump back to my board now. So basically what we're given is that, let's say for this one we have 2, for this one we have 10, for this one we have 5. It is not necessary that every block has a snow, but in whatever cell we have some number, that means it has snow. And this is the cost with which we can remove that snow. Okay. Similarly, we have some snow here, here, here as well. Our goal is to make all these friends from this position reach to this position. Okay. Now, what I'm going to do is I'm actually going to make a smaller grid, okay, to make you understand that one. Let's say n is 2. Let's say n is actually equals to 2. Okay. So we have a friend here, a friend here, a friend here, and a friend here. Let's say the cost of this is 2, 4, 2, 4, 4, 2, 2, 4. And let's say we have some snow here as well. So this is 0, this is 4, this is 2, this is 6. Okay. The very first thing that you need to realize is that this block should have no snow. Hence, we need to remove this, this, and this, and we have 4 plus 6 plus 2. This is the minimum snow that we need to remove because this is the final position of all our friends. Okay. So we need to empty these. Okay. Now, let's say we removed this cell, snow. Okay. If we remove this snow, what we can do is we can actually make this row come down. So this friend comes here and this friend comes here. So we have this as the next orientation. Then again, we can actually have this row move, this column move, this friend comes here. Now we can have this column moved 2 times. So this person will reach here. Okay. Then again, we can actually move this row once by down. So he reaches here. Then what we can actually have is we move this row by 1. So this becomes this. Then we again move this person to here. Okay. Then we again move him down. So he reaches here. Similarly, we can get these 2 people also here using this cell. Okay. We could have done the same thing using this cell as well. Or this cell, or this cell, or this cell, or this cell. Okay. So what you need to see is, now I need a bigger grid. Okay. So one thing is clear. We need to clear the bottom right grid because that is the final position of all our friends. And that needs to have no snow. Okay. But for all the other paths, okay, let's say this is the bigger grid that we have now. And I'll just mark it with the red one. Okay. We have a friend here, here, here. Okay. In all these values. Okay. One way to do this would be, we can actually use this path. Let's say we cleared this path. We cleared the snow from this cell, this cell, this cell, this cell. Okay. And we made all these values come down to this path. Okay. But in order to do that, you actually need to move any one, like, what do we say, row or column. And if you see, in order to move, like, let's say, okay, in any way, you will actually have to remove this one, or this one, or this one, or this one, or this one, this one, this one, or this one. Now, why is that so? Okay, let's say we took the very first, the 4th row. If we move this in a forward direction, we need to use this column. If we move this in a backward direction, we need to use this column. Similarly, if we took this column, if we need to move this in the forward direction, this cell will be used. If we move this in the backward direction, this cell will be used. Okay. Similarly, for this one as well, if we move the very first row in the forward direction, this cell will be used. If we move it in the backwards direction, this cell will be used. Similarly, for this one, if we move this column in the forward direction, this cell will be used. If we move it in the backwards direction, this cell will be used. What we realize from this is that we need to remove snow from either this cell, this cell, this cell, this cell, or these 4 cells. Okay. So the answer for this one would be, we first have to remove the snow from all the cells in the bottom right grid. Then we need to find out the minimum value of this, of all these four cells. Okay, whichever has a minimum value, we need to just add that to the bottom right one, and that is the final answer. I hope this is also clear to everyone. So this is more like an observation, and then you can do it. Okay, cool. Okay, so that's it for the stream. We had 4 questions solved in this one, and I hope everybody liked the stream. If you did, just like the stream and subscribe to the channel. I will. Okay, when's the next contest? Let's see. So the next contest is on 10th. Okay, we might have another contest in the middle of that also. So whichever comes with the next contest, I'll come live on that day as well to solve the first 3 or 4 problems. Okay. All right. I hope. Okay, cool.